Alright, I wanted to go over some 4 different problems, I guess, from practice 1.1b so that you can check your work. So let's get started. The first problem I'd like to go over is problem number 29, which says 7.895 divided by 34. This is a significant figures problem. And so in order to solve it, we need to determine, of all the numbers going into our solution, what is the number with the least number of significant figures? So we need to figure out 7.895 and 34. How many significant figures do they have? Let's take a look. First, the number 7.895. So this is number 29. The number 7.895. All right. When we're looking at sig figs, the first rule is the farthest left non-zero digit is significant. So in this case, that's a 7. The furthest right non-zero digit is significant. In this case, that's a 5. Next, the furthest right 0 is significant, but only if it happens after a decimal. Well, in our case, there is no zeros trailing out here. If this had been 7.895000, then the furthest right digit being a 0, a trailing 0 that occurs after the decimal, that would also be significant. But in our case, it's not the case. All right. The final rule is that any numbers that happen in between significant digits are significant. So in this case, that includes the 8 and the 9. You see 7.895 has 4 sig figs. Good to know. Next, 34. 34, I think we can see furthest left, furthest right, non-zeros. 34 has 2 sig figs. And so our answer needs to be represented with the least number of sig figs going in. So if we have 4 going in and 2 going in, the least number would be this 2. And so we're going to represent our answer with 2 significant figures. So we pull out our calculator and we type in, what is 7.895 divided by 34? And our calculator gives us, well, a big long number. It says 7.895 divided by 34 is equal to 0.232205882, probably keeps going on. And some people like to write out that whole big long number, but that's actually inaccurate. It implies more precision than we have. And so there's a right number of digits to write out. And let's find out what that is. Well, it's the number that would result in 2 sig figs. So we look at this number and we say, would this 0 ever be significant? Well, for 2 reasons it's not. First, it's the farthest left 0, which a 0 on the left can never be significant. Also, it doesn't happen after a decimal. And so that is not a significant digit. So basically, we have a 2 and a 3 here, and we only want 2 sig figs. We want to round our number off at that point. We looked at this next digit here and say, if this number is a 5 or more, then that I would represent this as 0.24. But in this case, as it's a 4 or less, I'm going to round down and represent this number is actually 0.23. That's writing out my answer to 2 sig figs. And that's the answer to number 29. Let's take a look at number 35. In number 35, in number 35, I have a big, huge, long number, and or 4 numbers, and each of them are represented with scientific notation. 4.1 times 10 to the negative third. Now that 10 to the negative third just means I'm dealing with a very small number. 10 to the negative 3 means I need to move my decimal point. Actually, it belongs 3 more spots over here to the left. It's like 0.004, whatever. All right. when we look for scientific notation, when we look for significant figures, we can ignore these scientific notation exponents. They have nothing to do with the number of sig figs. Rather, the number of sig figs is determined by this number out in front. So in this case, 4.1, well, that has 2 sig figs. 6.9, that has 2 sig figs. 7.2 times 10 to the negative 6, that's got 2 sig figs. 7.2 has 2. And 8.943 has 4 sig figs. So we're going to want our answer to have the least number, which is 2 in this case. So we're going to represent our answer to 2 significant figures. Well, what is the answer we get? Well, if I type that into my calculator, my calculator gives me something along the lines of this. It says, well, that is, all that stuff is equal to, I'll set this off to the side, is equal to 8.1739908. Probably, maybe yours keeps going or doesn't quite give you that many. But then it says times 10 to the negative 7 power. All right. How do we represent this number to 2 sig figs? Well, our 2 significant figures, if we started rounding it more and more and more, I mean, our 2 significant figures would have to, we would say we want 2 sig figs. We would want to round it off after the 10th place on this front number here, which because of this scientific notation is not going to be the 10th place. But you see what I'm saying. And when I look at this next digit after that spot, it's a 7, which means I want to round up. So I'm going to write this number as, to 2 sig figs, 8.2, and then I still have to keep this place value. So I'm going to write 8.2 times 10 to the negative 7 power. And that is the answer to number 35, to the correct number of sig figs. Let's take a look at number 37. Oh, I'll write up here number 35 just so you can keep that straight. All right, number 37. .37 is a unit conversion problem, and the problem asks us to take 450 millimeters and convert it into meters. So let's take a look at how we go about doing that. First, we need to see what the prefix milli stands for. That is to say, if I have 450 millimeters is equal to how many meters, I need to know this M here stands for milli, and it's a prefix before meters. And what is milli equal to? Well, if I look, I believe it's page 2 of your physics data booklet. There's a table of SI prefixes, and you can look up that milli means 10 to the negative 3. That is to say that you can replace milli with times 10 to the negative 3, and it's the exact same thing. So that we could say, if we wanted to just write an equality here, I could say that 1 millimeter is equal to, I can literally take this milli right here and replace it with times 10 to the negative 3 and write out 1, instead of milli, I'm going to write out times 10 to the negative 3 and then meters. You see that? So that this milli right here can just be replaced by this statement here, times 10 to the negative 3. All right, we're going to use this in our solution. So the way that we convert in physics is something I call the well-chosen 1 method. I'm going to start out with 450 millimeters, and I'm going to multiply it by a fraction where the top and the bottom are equal. This fraction is going to equal 1 because the top, the numerator, and the denominator are going to be the same value. And I'm going to elect to use this equality right here and take half of this equality and put it on the top and the other half and put it on the bottom. And the way that I'm going to decide which one goes where is I'm going to say that I want to take this milli here, these millimeters, and I want to cancel those out. So you can see that these are kind of like in the numerator, right? And when I multiply it by this fraction, in order to cancel millimeters in the numerator, I can almost, write that over 1. That doesn't change anything. If I want to cancel millimeters in the numerator, I need to have millimeters in the denominator, and that will cancel out. And so, in order to have millimeters in the denominator, this is going to be the denominator. I'm going to use right here 1 millimeter. I'm going to write down 1 millimeter in my denominator. I'll write it in bigger pen so you can see it even. 1 millimeter. And since this fraction that I'm putting in, that I'm going to multiply by, is going to equal 1, that is to say I want to have the numerator equal to the denominator. That's how a fraction is equal to 1. Like, if I take 7 over 7 or pi over pi, like these are all equal to 1. All right. So I'm going to use this side of the equality as my numerator because it is equal to the other side. So I'm going to write my numerator is equal to 1 times 10 to the negative 3 meters. And now this is equal to this, and this fraction is equal to 1. And as an added bonus, this is going to allow me to say, all right, well, 450, my result here is going to be a fraction, and to get the numerator, I take the product of the numerators, I multiply across the top, 450 times 10 to the negative 3, that ought to give me 0.45. So I'm going to say 0.45. For units here, I have millimeters here, and I have meters. So millimeters times meters. On the bottom, I have 1 times 1, that's 1. I have units of only millimeters. And now I can look and say, I have a millimeters on the top that cancels with the millimeters on the bottom, just like we've done before. I'm going to end up with units of only meters. So my result is going to be 0.45 divided by 1, that's just 0.45, and meters, 0.45 meters. 450 millimeters is equal to 0.45 meters. Great. Let's take a look at number 45. Number 45 is another conversion problem. I'm going to solve it the same way. So I have 0.00000272338 micrometers. 0.12345 zeros after the decimal, 272338 micrometers. I like to put that over 1, but it really doesn't matter. Times a fraction. And this fraction is going to cancel micrometers and get me into the units that I want to be in, which for number 45 is in meters. So I need an equality between micrometers and meters. And the way that I'm going to do this is this. I'm going to say, well, what is 1 micrometer equal to? It really hinges on this idea of like, what does micro mean? And so I look up in my data table what micro means, and in my data table it says this. It says, this page 2 says micro is the same as 10 to the negative 6. So I can write, instead of this micro here, I can just write times 10 to the negative 6. That is to say, the 1 I write and the meters I write, but instead of this micro, I just write times 10 to the negative 6. Excellent. This is going to allow me to, just like before, cancel out my micrometers on the bottom and my micrometers that would be on the top. And I just have to multiply through. So here's what we get. I'm going to have 0.00023 whatever 7 times 1 times 10 to the negative 6. And for a result for that, I get 2.7 times 10 to the negative 12. 2.72338 times 10 to the negative 12. And units on the top, I have meters over well, this is just going to be a 1 on the bottom, right? Because this is kind of like over 1. 1 times 1, no, my units cancel, over 1. Well, this is just going to give me 2.72338 times 10 to the negative 12 meters. Excellent. Man, that's a really small amount. I mean, negative 12, we're talking 0.1. Man, you can see why we would write it out in scientific notation. I should check to make sure I'm right here. 1, 2, 3, 4, 5, 6, 10, 11, 12. I think so. All right, rock on. Well, that's the end of those solutions. Hopefully, oh, not this answer. Don't write that out. The answer to number 45 is this right here. Excellent. All right, great. Hopefully you have this sorted out. If not, go ahead and watch the video a couple more times. Get yourself to the point where you feel comfortable. All right, take care. Bye.